Let us continue discussing redox reactions. In the redox reactions, we will balance the equation by ion electron method or off reaction method. For this, we will take an equation potassium dichromate in acidic medium reacting with oxalic acid to give chromium sulfate, then carbon dioxide, water, and potassium sulfate. Okay, this equation we have to balance by ion electron method, otherwise off reaction method. For which first write this equation in skeleton form. Skeleton form in the sense simple ionic form. We are writing this equation in simple ionic form. Okay, so skeleton form or simple ionic form, that is dichromate we are taking here. From oxalic acid we are taking oxalate, acidic medium H plus, product is chromium ion, then carbon dioxide. Water we will write later. Okay, so we have written the given equation in the skeletal form, simplest ionic form we have written. Next step, write oxidation numbers of each atom. Writing oxidation numbers of each atom. Sir, we will write oxidation numbers of each atom. We will write now. Oxygen -2. Oxygen is -2. This chromium is carrying +3, therefore +3 charge. Rest of the things we will find. Chromium we will find it. In dichromate, 2 chromium atoms present, 7 oxygen atoms present, net charge is equal to -2. This 2 chromium we have to find, oxygen -2 equal to -2. Therefore, we got chromium is +6. Then, in the same way, we will calculate for carbon, oxalate carbon, we will find it. Oxalate, C2, 4 oxygens, 2 carbons, 4 oxygens, equal to net charge -2. So, 2 carbons, oxygen oxidation number is -2, equal to -2. Carbon we are finding, carbon we are getting how much in the sense +3. Next, this carbon we will see, carbon dioxide. Carbon dioxide contains carbon and 2 oxygens. For oxygen -2 equal to net charge 0, therefore we have written 0. So we are getting carbon +4. So carbon oxidation number +4 we got. So next step, finding change in oxidation number. Remaining oxidation numbers we will remove it. So oxygen -2 we will remove. Oxygen is -2, that we have removed. Okay. We are considering change in oxidation numbers. Okay. So first chromium. Chromium oxidation number changes from +6 to +3. +6 is converting into +3. That is called decrease in oxidation number. Nothing but reduction. So chromium gains electrons. So gain of electrons per dichromate. Per dichromate, how much you will see? Gain of electrons per dichromate. So dichromate contains dichromate formula Cr2O7 2-. Here oxidation number of chromium is +6. That means charge of 1 chromium atom. For 1 chromium atom, +6. +6 is converting into +3 by taking how many electrons? 3 electrons. Here we want for dichromate ion, per dichromate ion, 1 dichromate ion. 1 dichromate ion contains 2 chromium atoms. 2 chromium atoms means 2 times +6. So each chromium takes 3 electrons and becoming +3. So 2 chromium atoms will take how many electrons? 2 chromium atoms will take how many electrons? 6 electrons per 6 electrons. Okay. So 1 dichromate ion contains 2 chromium. The 2 chromium atoms takes 6 electrons for converting into Cr3+. Okay. Then carbon will see. This carbon +3 is converting into +4. Plus 3 into plus 4 is called a increase in oxidation number, that is oxidation. Here plus 3 is converting into plus 4 by losing electrons. So loss of electrons. Loss of electrons per oxalate, how much you will see per oxalate. Oxalate formula C2O4 2 minus. Loss of electrons per oxalate we are finding. So this is this carbon, this one carbon atom charge is plus 3. Here oxidation number of carbon is plus 3 means for one carbon atom charge is plus 3. That plus 3 is converting into plus 4 by losing one electron. Oxalate contains two carbons. For each carbon charge is plus 3. Each carbon loses one electron and become plus 4. So oxalate contains two carbons. Therefore, each carbon losing one electron means totally how much loss in the sense 2 electrons. Okay. Next, equalize loss of electrons and gain of electrons. Next step, equalize loss of electrons and gain of electrons by multiplying with the suitable number. So multiply this with 3, multiply this with 1. So take oxalate 3 times, dichromate 1 time. So dichromate 1 time goes for reaction in the sense oxalate will go for 3 times. Sir. So dichromate 1 time goes for reaction in the sense oxalate goes for 3 times. Oxalate goes for 3 times. Gives this chromium Cr3 plus. Cr3 plus how many times means 2 times, because here chromium 2 times, plus carbon dioxide. Carbon dioxide, here carbon 6 times, therefore 6 times carbon dioxide. Now loss of electrons and gain of electrons are equal. Next, remaining thing we have to balance by hit and trial method. Okay. Now oxygen. Here oxalate oxygen is balanced in the carbon dioxide. So dichromate oxygen alone we will consider. Dichromate contains 7 oxygens. So right side write 7 water molecules. Here 14 hydrogens are there. Therefore this side write left side 14H plus you write it. Now you see that now we have to balance the charge. Charge only has to be balanced. That is last. That is the last thing should be balanced automatically. Okay. Sorry. Last thing should be balanced automatically. Sorry. Now we will see the charge whether it is balanced or not. We'll see. Here -2 charge. Here 3 into -2 -6. 14 into +1 +14. So how much in the sense here charge is 6 we can say. +6 charge is +6. Right side we will say 2 into +3 +6. So charge is balanced means equation is balanced. So we have written balanced equation in the ionic form. Now we will write this ionic form into the given form. Given form is this. As per this we will write. Sir. Now dichromate is 1 time. Okay. Dichromate 1 time dichromate you will get from 1 time potassium dichromate. So 1 potassium dichromate will give 1 dichromate ion. Sir, okay, it is balanced. 1 oxalic acid, 1 oxalic acid molecule will give 1 oxalate ion, but we want 3 oxalate ions. Therefore, take 3 oxalic acid molecules. Then Cr3 plus 2 times present. Here chromium sulfate contains 2 times chromium. Okay, it is balanced. Carbon dioxide 6 times. So write 6 carbon dioxide. Then water molecules are there. Water molecules 7 is there. Therefore write 7 water molecules. But 7 water molecules we have written, but water molecules we will write later. We will check some other thing, then we will write water molecules. Okay. Now we have balanced dichromate, we have balanced oxalate, we have balanced chromium 3 plus, we have balanced carbon dioxide, we have balanced. Now remaining things we will see. Okay. Here potassium is 2. Here also potassium is 2. Now we will balance sulfate. Sulfate 3 times here. Sulfate is 3 times here. Here 1 time. That means sulfate is 4 times. Sulfate 3 times here. Here 1 time, 4 times. Therefore, we will write sulfuric acid 4 times. Now we will see oxygen. Oxalate oxygen is balanced in carbon dioxide. Sulfate oxygen is balanced in sulfate. Dichromate oxygen alone we will see. Dichromate oxygen 7, that is converted into water molecules, therefore 7 water molecules. Now hydrogen is the last atom. That balancing we have to see. That is the last one, means last one should be balanced automatically. Then only the equation is correct. Equation is correctly balanced. Now we will see hydrogen. Here 7H2. Here 4H2. Here 3H2. 4H2 plus 3H2, 7H2 here. Here also 7H2. Okay. So equation is balanced. Sir, here when we are balancing this ionic form, to balance oxygen, what we have done? Water molecules we have used. Okay. To balance hydrogen, we have used H plus ions. Why? Because this reaction takes place in acidic medium. Okay. So this step again I will say, to balance oxygen, we have used water molecules. Like that only we have to do. To balance hydrogen, we have used H plus ions. Why? Because this reaction takes place in which medium? Acidic medium. That's why. Okay. Sorry. Next equation we'll take for balancing, same ion electron method or off reaction method. We'll take a potassium permanganate, sulfuric acid, then ferrous sulfate, then MnSO4, ferric sulfate, water, K2SO4. Okay. Now this redox reaction is there. Let us balance this redox reaction by ion electron method or off reaction method. By ion electron method or off reaction method, let us balance this equation. Sorry. Ion electron method or off reaction method means, first write the given equation into skeleton form, otherwise simplest ionic form. So for that, we have to convert these species into ions. These species present in aqueous solution. In aqueous solution, these are present in the form of ions. That ions we have to write. That ionic form we have to write. Okay. So potassium permanganate contains K. Potassium is first group. First group element means that you write in the form of ion. Rest of the thing you write separately. MnO4 minus. Here plus means here minus. Mn and oxygen don't split. Then sulfuric acid we can write H plus ions and sulfate. Sulfate don't split as sulfur and oxygen. It is ferrous sulfate. Ferrous sulfate contains ferrous ions and sulfate ions. Then manganese sulfate. This sulfate we can write SO4 2 minus. Therefore Mn2 plus is separate. This is called ferric sulfate. Cross multiply. The ferric is Fe3 plus. Sulfate is SO4 2 minus. Water don't split, right as it is. Potassium sulfate split as K plus ions and sulfate ions. Okay. Next, cancel the spectator ion. Spectator ion means which has same oxidation number in the reaction. That means which is not involved in chemical reaction. Which one? That we will see. Here you see K plus. Here you see K plus. So K plus, is it involved in chemical reaction? No. Potassium oxidation number here remains same. So let us remove potassium. Okay. So let us remove potassium. Okay. We will cancel potassium now. So K plus we are cancelled. Then you see in all the places sulfate is there. See, no change for sulfate. So cancel sulfate. We have cancelled sulfate. What is the remaining that you take? Permanganate is the remaining. You take permanganate. MnO4 minus. Ferrous is remaining, that you take ferrous Fe2 plus. This H plus indicates acidic medium. Acidic medium, we write H plus and the over the arrow mark. Right side Mn plus 2 is there, that you write. Ferric is there, Fe3 plus, that we are writing. Water molecule we need not write. Later when we are balancing, we will write water molecule. Okay. Sorry. Or if you want to write water molecule also, we can write. Sorry. Next step. Writing oxidation numbers of each atom. This oxygen we know -2. This Fe is containing +2. That +2 is the oxidation number of Fe. This Mn is having charge +2. This Mn is the Mn oxidation number is +2. Fe oxidation number is +3. Here manganese oxidation number, let us calculate. In the permanganate, manganese 1 time is there. Oxygen 4 times is there. Oxygen is carrying -2 charge. Net charge is -1. Let us find manganese oxidation number, that is +7. Next step. Consider change in oxidation numbers. Remaining, neglect it. Okay. Oxygen oxidation number is -2 here. In water also, this oxygen will convert into water, no doubt. In water also, oxygen oxidation number is -2. So we need not consider this oxygen oxidation number. Okay. Rest of the things we will consider. Manganese +7 is converting into +2. Manganese +7 is converting into +2 by gain of electrons. Therefore, manganese undergoes reduction. Gain of electrons. Gain of how many electrons? Per permanganate. That we have to see. Per permanganate, how many? Permanganate contains 1 Mn. That +7 takes 5 electrons and becomes +2. Sorry, Fe2 plus you'll see. This Fe2 plus is converting into Fe3 plus by the loss of electrons. By the loss of electrons. Per Fe2 plus, how many we'll see. For Fe2 plus, how many we have to check. Okay. 1 Fe2 plus ion losing 1 electron and become 1 Fe3 plus. Next, equalize loss of electrons and gain of electrons. Now we have to equalize loss of electrons and gain of electrons. Okay. To equalize loss of electrons and gain of electrons, multiply this with 5, this with 1. Now here loss of electrons become 5, gain of electrons become 1. Therefore, you take permanganate 1 time. Okay. So we are taking a permanganate, how many times means 1 time permanganate we are taking. Fe2 plus, how many times we are taking? 5 times we are taking. 5 times Fe2 plus we will take. Gives Mn plus 2. Mn plus 2, how many times produced in the sense? Here 1 time manganese is there, so 1 time Mn plus 2. Okay. Then Fe3 plus. Fe plus 3, ferric. Ferrous 5 times undergoing oxidation. Therefore, we will get ferric how many times in the sense? 5 times ferric we will get. You will get ferric how many times means 5 times ferric we will get. Okay. So manganese is 1 time, here also manganese 1 time, Fe is 5 times, here also 5 times. Then we have to balance oxygen. This oxygen is converting into water molecules. 4 times oxygen means write 4 times water molecules. To balance oxygen, use water molecules. Here 4 oxygen is there. So write this side 4 water molecules. So oxygen is balanced. Then balance hydrogen. Here 8 hydrogen atoms are there. So here what you have to write means 8 times H plus you write. Why H plus means acidic medium. Therefore H plus. So to balance hydrogen, you are using H plus because medium is acidic. Here see sulfuric acid we have taken, acidic medium. So to balance hydrogen, we are using H plus ions. Okay. Now we have balanced this ionic form of equation. At last, charge is there. If charge is balanced, the equation is correctly balanced. Okay. Here charge is -1. Okay. So now here in this equation we have balanced the hydrogen by giving H plus. Why we have balanced this equation, this hydrogen by using H plus? Because the medium is acidic. How do we know the medium is acidic? See this. What is this one? Sulfuric acid. Sulfuric acid is there in the chemical reaction, means medium is acidic medium, isn't it? Sulfuric acid is there in the chemical reaction, therefore medium is acidic. Okay. Now we will see charge balancing. If charge is balanced, then this ionic form of equation is correctly balanced. That is the meaning. Okay. So -1. Here permanganate contains -1 charge. Fe contains +2. 5 into F. 5 into +2. 5 into +2 +10. Here 8 into +1. Here 8 into +1 +8. Therefore +17. +17 is the charge left side. Right side you see. Here +2. Mn contains +2. Fe 5 into +3 +15. Therefore equal to +17. Okay. Charge is balanced. That means we have balanced correctly this ionic form. Now we have to give the balanced equation as per the given. The given equation is this. As per this, we have to give the balanced form. Okay. Now we want permanganate one time. So how many times potassium permanganate we will take? One time you take it. One time potassium permanganate will give one time permanganate. But here potassium permanganate, in the potassium permanganate, potassium is converted into potassium sulfate. Potassium sulfate contains 2 times potassium. So we have to make permanganate 2 times. If you want to make permanganate 2 times, multiply this entire ionic form of equation by 2. Okay. So by 2 you multiply it. So this entire ionic form we are multiplying by 2. Why we have multiplied by 2? Because in this we have to give balanced equation as per this. Because they have given this equation only with no. So we have to give the equation balanced form in this form only, not the simplest ionic form. We have taken simplest ionic form for our convenient. Set. So here potassium is 2 times is there. So we must take potassium permanganate 2 times. Then that means potassium permanganate 2 times means permanganate 2 times. Permanganate 2 times we want means multiply this entire ionic form by 2. Then only loss and gain of electrons will be equal, otherwise it will change. So permanganate we have multiplied by 2, so potassium permanganate 2 times. Okay. Then ferrous 5 times is there. We are multiplying this entire form by 2. Therefore 5 into 2 10. 10 times ferrous ions. So take ferrous sulfate 10. So ferrous sulfate you are taking how many means 10 times ferrous sulfate you are taking. So we are taking ferrous sulfate 10 times. Okay. Then H plus we have to balance. We will see at last. Okay. Then Mn2 plus. Mn2 plus we are multiplying by 2. Therefore 2 times Mn plus 2. Here also potassium permanganate contain 2 times. Therefore Mn is 2 times. Okay. Then we are multiplying ferric by 2. Therefore 5 into 2. 5 into 2 10 times ferric. 10 times ferric. Here ferric should be 10 times. Okay. Here ferrous ion Fe is 10 times present in the left side. Fe present 10 times in the left side. Here Fe 2 times present in a molecule. We want to make Fe 10 times. So multiply this with 5. 5 times ferric sulfate means 5 2s are 10. 10 times Fe. Here also 10 times Fe. Okay. Then we will balance. Sulfate we will balance. First you see sulfate in the right side. Here 2 times sulfate. Here 5 3s are 15 times sulfate. Here 1 time sulfate. So total how many? Here 2 times sulfate. 5 3s are 15 times sulfate. 1 time sulfate. So 18 times sulfate is there. 18 sulfate is the right side. Left side. Here 10 times sulfate. Here 10 times sulfate. Remaining is how much? 8. Therefore 8 times sulfuric acid. Sulfuric acid 8 times. Now everything we have balanced. Last one hydrogen is there. If hydrogen is balanced, then okay. 8 times H2. Here 8 times H2. 8 times H2. Okay. Now oxygen also is there. Okay, sorry, we have balanced hydrogen. Now we will check oxygen. If oxygen is balanced, then it is okay. Here potassium permanganate, here two fours are here oxygen present in potassium permanganate. These two fours are 8 oxygen. Don't consider sulfur oxygen because sulfur oxygen is balanced. You consider this potassium permanganate oxygen 8 times is there. So water also 8 times. Therefore, water also 8 times in the sense we can say that this oxygen is balanced, we can say. So oxygen is balanced in the sense the equation is balanced equation. Okay. So in this way we have to balance. This method is called ion electron method or off reaction method, we can say. Sorry. Next we will take next equation, bromine, potassium hydroxide gives KBr and KBrO3 plus water. It is the equation. This equation we have to balance by ion electron method or off reaction method. So how to balance, we will see. First, let us write this one in simplest ionic form. Let us write this one in the ions. Ionic form we will write. Bromine is covalent molecule, so it will not split into ions. So write as it is. Potassium hydroxide is a strong base. It will split into K plus ions and OH minus ions. Potassium bromide is a salt, therefore K plus ions and Br minus ions. Potassium bromate, write K plus ions. Bromate, write separately BrO3 minus. Bromine and oxygen don't split. Water you write as it is. So cancel the spectator ion. So what is the spectator ion here? K plus. So cancel K plus. So we will leave the K plus. Remaining things we will take. Okay. So remaining things. Remaining is what? Bromine. OH minus indicates basic medium. Okay. Br minus, right side Br minus is there. BrO3 minus is there. Water we will write later. Set. So we have taken bromine. OH minus we have written above the arrow mark because basic medium. Br minus and BrO3 minus we have written. Next, write oxidation numbers. Now we have to write what in the sense? Oxidation numbers we have to write. So bromine is element, therefore 0 is the oxidation number. Bromine is element. So for this oxidation number, how much means 0? Br is having -1, so oxidation number -1. In BrO3 minus, oxygen is having -2. Bromine, if you calculate, you will get how much in the sense? +5 you will get. In the hydroxide, oxygen is having -2. Here also oxygen is having -2. Therefore, oxygen oxidation number has not changed. So don't consider oxygen oxidation number. Rest only we will consider. Now, here, this bromine 0 oxidation number is converting into bromine -1 oxidation number. So we will write bromine 0 oxidation number is converting into bromine -1 oxidation number. Okay. Bromine 0 oxidation number is converting into bromine -1 oxidation number we have written. Next. Bromine 0 oxidation number is converting into +5 oxidation number bromine. That we will write. Bromine 0 oxidation number is converting into +5 oxidation number of bromine. Now, here 0 oxidation number is converting into -1. 0 is converting into -1 means gain of electrons. Therefore, we can call this is as reduction of reaction. Reduction of reaction. Here bromine is 0. 0 is converting into +5 bromine. That means 0 is converting into +5 means it is called oxidation of reaction. Oxidation of reaction. So in this place, bromine undergoes reduction. Here bromine undergoes oxidation. So same element undergoes oxidation as well as reduction means it is called disproportionation reaction. It is called disproportionation reaction. Then here we will balance bromine now. Here bromine is 2. Here we will make bromine 2. So Br2 gives 2 times Br minus. Here also we will balance bromine. So Br2 gives 2 times bromate. 2 times bromate. Bromine is 2 here. Here also bromine is 2. Okay. Next we will balance oxygen. We will balance. Here oxygen is 3 2s are 6 oxygens. So write 6 water molecules here. So Br2 plus 6 water molecules gives 2 BrO3 minus. Okay. So we have balanced what in the sense we have balanced oxygen. Okay. Here 6 oxygens are there. Therefore write 6 water molecules here. Next, balance charge by giving electrons. Here charge is 0. Here charge is 0. Here -2 charge. Therefore, how to balance charge by giving electrons in the sense, here write 2 electrons. If you write 2 electrons, here -2 charge, here also -2 charge. Okay. Then also see, reduction means gain of electrons. See, bromine gains 2 electrons and becomes 2 times Br minus. It is 0 oxidation number. It takes electron and become Br minus. So reduction. Here let us balance charge. Here charge is 0. Left side charge is 0. Right side -2 charge. Right side charge, if you see, -2 is there. So how to balance charge here? Which side shall we write electrons? It is oxidation. Oxidation in the sense loss of electrons. Loss of electrons means which side electrons should come? Right side only electrons should come. But how to write a right side electrons? We cannot write a right side electrons, no? Yes. Because we have not balanced hydrogen. Without balancing hydrogen, we have gone for charge. Sorry. First we will balance hydrogen. Right? Here let us balance hydrogen, then we will go for charge balancing. Okay, now we have to balance hydrogen. Here hydrogen 12 times present. Now we want to balance hydrogen. Here medium is basic medium. Medium is basic medium. Now we have to balance hydrogen in the basic medium. In the basic medium, how to balance hydrogen, that we will see. In the basic medium, how to balance hydrogen. Now, here hydrogen is there. We have to balance hydrogen by considering the medium is basic. Medium is basic. Now, medium is basic means what is the rule to balance hydrogen? That you see that. Here, how many hydrogens are there? You see, 12 hydrogens. Here, how many hydrogens deficiency? 12 hydrogens. That many water molecules, you write it. That many OH minus you write on opposite side. Like this, we have to balance hydrogen in basic medium. Okay. So how to balance hydrogen in basic medium? Again, I will say, see, now here how many hydrogens are there? 12 hydrogens. Here how many hydrogens deficient? 12 hydrogens. That many water molecules, right? How many hydrogen atoms are deficient? That many water molecules. 12 hydrogens deficiency means 12 water molecules you write. How many water molecules we have written? That many OH minus you write opposite side. 12 water molecules we have written, therefore 12 OH minus you write in the opposite side. Okay, like this only we have to balance hydrogen in basic medium. But in the previous case, in the acidic medium, we have balanced hydrogen just by giving H plus. Acidic medium means H plus we can use for balancing hydrogen. Basic medium means we have to do like this. Directly OH minus, don't use it. Okay, sir. Now we will cancel here 6 water molecules, here 12, 6 if we cancel. Remaining what is there? That you write here Br2, 12 OH minus gives 2 BrO3 minus plus 6 water molecules remain. Out of 12, 6 is remain. Okay, now we have to balance charge. Okay, so let us balance charge. Here 12 into -1 minus 12 is the charge. Here 2 into -1 minus 2. So here -12, whereas here -2. Balance the charge by using electrons. Therefore, here add 10 electrons. If you add 10 electrons, 10 electrons means minus 10. Here minus 2 is there. So minus 12 here. This side minus 12. This side also minus 12. So we can say charge is balanced. We can say. Okay. It is a oxidation of reaction. Oxidation means loss of electrons. See, loss of electrons. And another one we have seen, reduction of reaction, that is Br2 gives 2 Br minus here plus 2 electrons. Reduction of reaction is like this. Reduction of reaction means gain of electrons. Oxidation of reaction means loss of electrons. Next step what you have to do means equalize gain of electrons and loss of electrons. To equalize, what we have to do? To equalize gain of electrons and loss of electrons, multiply this with 5 and multiply this with 1. Now see, 5 2s are 10 electrons. Here 110, 10 electrons. Loss and gain equal. Okay. Next, let us add this oxidation of reaction and the reduction of reaction. Now, oxidation of reaction will take, that is Br2 plus 12 OH minus gives 2 BrO3 minus plus 6 times water molecules plus 10 electrons. Then we will take reduction of reaction. Reduction of reaction, you multiply this with 5. So 5 Br2 plus 10 electrons gives 10 Br minus. Okay. Now we will see overall reaction. We'll see. Now 10 electrons will cancel. 5 Br2 plus Br2, 6 Br2. 12 OH minus. Then right side what is there means 2 times BrO3 minus, 10 times Br minus plus 6 times water molecules. Okay. Then all the coefficients are even numbers. Therefore, we will divide the whole equation by 2. So we will get 3 times bromine, 6 times OH minus, 1 time BrO3 minus, 5 times Br minus, and 3 times water molecules. Okay. Then this Br2 we will write as it is. Br2 will write as it is. OH minus is from potassium hydroxide as per the given equation. So potassium hydroxide will write. BrO3 minus is from potassium bromate. KBrO3 will write. Bromide is from potassium bromide. Therefore, KBr will write plus 3 water molecules. Okay. Now the equation is balanced or not, that we will check by using potassium. Here 6 times potassium, here 1 time, here 5 times. Here therefore 6 times potassium in the right side. Left side also 6 times potassium. Therefore, we can say the equation is balanced equation. In this way only we have to do the basic form balancing. So in the basic form balancing, what is the difference in the sense only hydrogen is different. Only hydrogen balancing is different. So again I will say how to balance hydrogen alone in basic medium, I will say. Okay. How to balance hydrogen in basic medium, that point I will say. Now you see that here hydrogen is 12. Here 12 hydrogen atoms are deficient. Therefore, write 12 water molecules. How many water molecules you have written? That many OH minus ions you write opposite side. 12 OH minus ions. Like this, we have to balance hydrogen in basic medium. Okay. So in basic medium, we are balancing hydrogen like this. But in acidic medium, directly we can use H plus ions for balancing hydrogen. Basic medium means like this only we have to do. This is called a balanced equation, we can say. Let us complete.